every object around us has an impact on the environment. In this lesson, we will see how this impact is generated, the criteria for evaluating it, and the approaches for designing a product with low environmental impact. But what exactly is the environmental impact of a product? First of all, it is important to specify that environmental impact is not generated only during the use of an object, but is distributed along the entire chain of processes that make its existence possible. From pre-production, that is, the extraction of raw materials and the production of materials, to manufacturing and distribution, all the way to use and disposal. The impact is the alteration of the environment generated by the exchange of substances between the product system and the natural ecosystem, that is, the geosphere and the biosphere, both direct and indirect, that accompany the product throughout its entire existence. We can distinguish two main flows: the inputs, meaning the resources taken from the environment, such as minerals, fossil resources, water, and so on, and the outputs, that is, the substances returned to the environment, namely emissions into air, water, and soil. When these exchanges lead to a deterioration of environmental conditions, we speak of a negative environmental impact. Such impacts can vary in magnitude, duration, and reversibility, and they are not always immediately visible or localized. We can classify their harmful effects into three main categories: ecological damage, such as climate change or acid rain; damage to human health, including carcinogenic and non-carcinogenic toxicity; smog, reduction of stratospheric ozone; and resource depletion, which concerns the consumption of water, mineral, fossil, and renewable resources beyond their rate of replenishment. But what are the design approaches for assessing the environmental impacts of a product? There are two: the life cycle and the functional unit. For the product's life cycle, the approach known by the common term life cycle thinking is used, which considers the product in relation to the environmental impacts generated by all the inputs and outputs of the processes involved in each phase of its existence. The main phases of the life cycle are five. The first is called pre-production and includes all the processes necessary for the production of materials: the extraction of raw materials, their transport to the production site, and their transformation into materials. In this phase, it is possible to distinguish between primary resources, meaning virgin resources, and secondary resources from recovery or recycling, as well as between renewable and non-renewable resources. The second phase is the production phase, which includes the processes of transforming materials into components, assembling, and finishing the product. Here we distinguish between direct materials, which remain in the final product, and indirect materials, which are used in the process but are not incorporated into the product, such as lubricants, solvents, and process water. At the end of production comes distribution, which involves all the processes necessary to bring the product from the production site to the user and includes packaging, which can be primary, secondary, and tertiary, such as product boxes, shipping cartons and pallets, as well as transportation and storage. This is followed by the use phase, which, depending on the type of product, may consume mineral or energy resources and contribute to various types of emissions. In addition to direct consumption, there may also be other processes related to maintenance, repair, upgrading, or adaptation services. Finally, we have the disposal phase, which may include reuse, that is, giving the product or some of its components a second life, remanufacturing of parts or assemblies, recycling of materials, composting if possible, energy recovery, or in the worst case, controlled or uncontrolled landfill disposal. Adopting a product life cycle approach means extending the design horizon. You no longer design just the product itself, but its entire life cycle. However, to properly assess the environmental impact of a product, it is not enough to consider only its life cycle. It must also be considered in relation to the functional unit. This is defined as the quantified performance of a product system and is to be used as the reference unit in a life cycle environmental impact assessment. This definition implies that the object of the analysis is not the product itself, but the set of processes required to provide a specific performance for a given duration and period of use. Let's look at an example. Actually, let me ask you a question. Which has a greater environmental impact? A seat made of recycled cardboard assembled with interlocking joints, or a chair made of plastic, metal, and other materials designed to last over time? If we look only at the product itself, the cardboard chair has a very low impact. It is lightweight, made from recycled and recyclable materials, and is easy to transport. However, its useful life is extremely short. In fact, cardboard deteriorates easily. On the other hand, a chair designed to last several years, 15 for example, even if it has a more complex structure made up of materials, production processes, distribution, and disposal methods that certainly have a greater environmental impact, can still turn out to be more sustainable. In fact, if it is designed to last over time with components that are easily replaceable in case of breakage or the need for an upgrade and are easily recyclable, things can change drastically. In fact, if the functional unit is defined as a seating station available for 15 years, it would be necessary to pre-produce, manufacture, distribute, use, and dispose of countless cardboard seats to achieve the same performance over time. If we consider the overall environmental impact taking the functional unit into account, then this would be much higher for the cardboard chair. The functional unit therefore allows us to shift the focus from the object to the function, avoiding distorted assessments. This approach thus shifts the design reference from product design to design based on the functional unit. Thanks to the life cycle approach and the functional unit approach, we are able to properly set up the development of a new product so that it has the lowest possible environmental impact. This systemic approach to designing products with low environmental impact is known as ecodesign or life cycle design. You no longer design just a product, but rather the entire system of processes that make up its life cycle in relation to its functional unit. Life cycle design, with the two approaches just defined and with the goal of reducing environmental impact, is, in summary, the design discipline that integrates environmental requirements into the product development process. Designing with a life cycle and functional unit perspective therefore means transferring the intention and responsibility for low environmental impact design into a solid operational framework. This is a necessary step to make a concrete contribution to reducing the environmental impacts of every product we will have to design now and in the years to come.